What is up, everyone? Welcome back. My name is Matt. This is Made with Matt, and in this final video of the Crypto Price Tracker series, we'll be populating our app with real live data. So just a recap from the previous video, what we've accomplished is set up this bottom sheet. We also have this really nice list in here, and we could jump between them. We could check out different prices like that, and we could close it. But now we could see that it's using some sample data right over here that we had included in the first video. And now we'll go get it from an API. So the API that we'll be using is the Coin Gecko API. So it's a free cryptocurrency API. And if we click Get Started, it'll bring us down to all the endpoints that we could hit. So for what we need is we just need a list of coins with their price and some other market related data. So if we click this one, we could actually try it out in here, which is really fun. So we click try it out, and in here we want versus currency. So what's the target currency that you want to basically put up the crypto against? So we'll use USD, and then we can scroll down. Sparkline, yes, we'll want a 7-day Sparkline because that's what's going to give us the ability to create the chart. And then for the price change percentage, we want the 7-day. So let's put 7D, just like that. Click execute. And here we'll see a bunch of coins show up. Now this list is pretty long. What we could do is actually cap it at a certain number. So right now per page there's 100. Let's change that to 20, just so that we don't have too many and it doesn't take too long to load. Perfect, so we have this all here. What's really nice about this API is that it fully gives us the request URL that we need. So we can just copy this and we'll be using this afterwards to create our API call. So I've got the app running here. Once again, to get it running, Expo Start in your terminal. It'll open up this page over here. You could scan this QR code and then you could run it on your phone, or you could run it on one of the simulators. So what we'll do is create a new folder in here. So new folder, we'll call it services. And the purpose of these, or this folder, is to store our network services or our network calls, which is basically our calls to the API. So let's create a new file here called cryptoService.js. And this is where we're going to be putting all our functions that actually make the API calls. So let's get started by creating the first one. So export const getMarketData. And we'll have a try catch in here, since we'll be doing an API call that returns a promise. It's possible that there's an error. And if we do have an error, we'll just console log the error.message like that. In here, we'll do the API call. So we'll say this is where the API call will go. And we could just paste in up here the actual URL that we need to go to. So to make API calls, whether it's React or React Native, one really good package to use is Axios. So we could go ahead and type in yarn add Axios. Once it's been installed, we'll go to the top here and say import Axios from Axios, just like that. And now what we could do in here is a const response is equal to axios.get, and we could pass in this URL. So axios.get the URL. And one thing that's a good idea to add is making this asynchronous. So adding await and async on top here. Now what that does is basically the code is kind of going to stop here and wait for this response to come back before continuing and before returning this response to wherever it needs to go next. So let's get the data from the response. So response.data, and this is something specific to Axios where the data is held within the response.data object. Next, we'll say const formatted response is equal to format market data and pass in the data. And this is a function that we're going to implement in just a second. Finally, we'll return the formatted response. So this is how we'll be moving through it. Basically, we'll call this function from App.js. Once we call it, we'll send a request to the API to get some data. Once we've received that data, then we'll parse it properly so that it fits our needs. And then we'll return the formatted response. So let me just clean that up. Awesome. So just moving above here, we'll create a new function called const formatSparkline. And this one is going to take in some data, or I guess it could take in numbers, and it's going to return a different format for the sparkline. And this is a function that we'll call from this function here. So let's just go see why we're doing all of this. So if we scroll down in the sample response from Coin Gecko from the API, we could see that the sparkline for 7 days comes as a price array with just numbers. The issue with this is that for our chart, so if we jump to our chart, for our chart, we need two separate values. So we need X values and Y values. And the Y values correspond to the price, which we see changing here. But the X values correspond to the time. So since this is 7 days, the X value over here is 7 days ago, and the X value over here is basically right now. So we need to format the sparkline, or in other words, we need to format this array for each index to have an X and Y component, where the X component refers to the time and the Y component refers to the price. So that's what we're building out here. So we could start by saying const 7 days ago is going to be equal to, and now we need to get 7 days ago. So to do that, let's install another package called moment. So yarn add moment. And moment facilitates all this date handling for us to make it really, really easy to subtract 7 days from today. So let's just import it. So import moment from moment. And we'll say 7 days ago is moment dot subtract. And this is how easy it is. We could say 7 days and just convert that to Unix time. And there we go. We have 7 days ago. Now what we'll do is we'll say let formatted sparkline equal data, or in this case, we'll say numbers dot map. And we'll have item and index. This will call an arrow function, and in here we'll return an X component and a Y component. So the X component is going to be 7 days ago plus the index plus 1 times 3600. And what this is going to do is for each item in the array, it's going to increment the X value or the time value by 1 hour, which is what 3600 is in seconds. And for the Y value, we'll just say item. So there we go. Now we could implement the formatMarketData function. FormatMarketData. So this is going to take in some data, and we'll say let formatted data equal an empty array for now. And we'll say data for each. So for each element, and we'll call this element item. So for each item, we'll say const formatted sparkline is equal to, and then we'll call this function formatted sparkline data dot sparkline in 7 days dot price, which is Sparkline 7 days dot price gets us that array. So we're passing in the array over here and we're getting X and Y values afterwards. So once we've done that, then we could say that the const formatted item, so this is just going to be one item in the data, is going to be an object with all the same values from the item above. So one of the items in the data, but we're going to update the Sparkline in 7 days so that the price is this value over here. Next, we'll append some values to this formatted data dot push formatted item like that. And in here we could say formatted return formatted data. Awesome. So now we've got everything set up in here. Just rereading this, I noticed that we don't have a return statement. So let's go return formatted Sparkline. And we're good to go test this in App.js. So we could jump to App.js, and in here we'll create a new state. So we'll call this data set data is equal to use state, and open close brackets. Default value is going to be an empty array. And then what we could do is call a use effect. So use effect, this one here. And we only want this to run at the beginning one time, which is why we leave empty dependencies for the use effect. So we'll say const fetch market data is equal to an async function, and const market data will be equal to await get market data. Now we need to import this function. So let's import it, import getMarketData from services, cryptoService. And now once we have that market data in here, we'll set the data as market data like that. And then we'll call this function. So fetch market data. Boom, there we go. Now the last thing that we got to do is actually use this data. So we'll move down to the FlatList and remove the sample data and replace it with our data. Now we see that it's not working yet. We could go check our console and we see that undefined is not an object, evaluating data.sparkline. Okay, so let's go back to our cryptoService and figure out where this line is. So we could just copy it and paste it in. There it is. And the issue here was that we were calling data instead of item. Sorry about that. So now we save it and there we go. Now we have all the different coins and it goes up to 20. So you might have noticed that now we're almost at the end of it. We have a couple of bugs that we need to fix. Luckily for us though, they're actually pretty simple to fix. So the first one, if we click Bitcoin here, we can see that everything works properly. But if we go ahead and click the next item and hover over it and click through, when we let go, it goes back to the previous price of Bitcoin instead of actually going to Ethereum. And this is true as well if we go to this one over here, it goes back to 32. So that's the first issue. Second issue is if we close it and open up a new coin, we see that it's empty, but we could still press on the chart and see the dot. So we'll go ahead and jump back into chart.js and get started solving these issues. The first issue that we have that we mentioned is over here. Let me just reload it. Over here, when we click, let's say Ethereum, notice the number 1,900. Then we click Bitcoin, we click on the chart, and it goes back to 1,900. The reason for this is because the chart is being the value here is being rendered in a worklet, which runs on the UI thread. And even though we're passing in the current price, which comes in as a prop, this is running on the JavaScript thread, and then we're passing it in here, but this is actually running on the UI thread. So I believe what's happening is that it's getting confused as to which value is actually the current price, and there might be a delay where this current price isn't being updated properly. So to fix this, we could create a shared value that is going to be shared between the UI thread and the JavaScript thread. And that actually comes from React Native Reanimated. So the first thing we'll want to do is up here, we'll say const latest current price, and that'll be equal to use shared value. And by default, it'll import it. If it didn't, you can do so. And luckily, we already have Reanimated installed for the charts. So jumping back here, use shared value, and the initial value is going to be the current price. Next, what we could do is we can create a use effect. So use effect, just like that, and make sure you import it from React. And what this use effect is going to do is whenever the current price changes, so these are the dependencies of the use effect, and in here we're passing in current price. So whenever current price changes, we'll want to set the latest current price dot value equal to current price. So the reason we need to do dot value here is that's just the notation that React Native Reanimated uses for shared values. And you could read a lot more about this in their documentation for React Native Reanimated. So basically what this is doing, to recap, is every time the current price gets updated as a prop in this component, the latest current price dot value gets set to equal to the most up-to-date current price. And that way, now this value, latest current price, could be used between the UI and JavaScript thread to reflect the actual latest current price and not maybe the one from before or something like that. The last thing we'll have to do to fix this now is go down here, and instead of current price, we'll pass in latest current price. Make sure to say dot value. And if we save it now, let's just reload it to be sure. Awesome. Click Bitcoin. Okay, looks good. Go to Ethereum. If we let go, we could see that it stays at the correct number. Like that. Awesome. Now, if we close this and click another one, we could see that we still have the other issue. So let's fix that. So for this issue over here, I did some digging in the actual library. And it seems like a common issue where on the first render of the chart, so if we open it for the first time, it works perfectly. But if you close it and basically re-navigate to the page with the chart, it doesn't end up working, and you see this that we see on the screen right now. So I'm not exactly sure the issue. I try my best to dig into it and figure it out. What it does seem like, though, is that on the first render, the chart has all the right data and everything that it needs to render properly, but it seems like after you close it and click on a new item and re-navigate to it, there's some sort of delay where the data isn't being populated properly, and because of that, when we render our chart, it doesn't actually show the line, but we could still click over it. So there's actually a really simple workaround for this, and basically what we'll do is we'll add a fake delay to the loading of the chart. That way we know the data gets there on time, and we know that the chart could be rendered. So to do that, right under here, we could create a state. So we'll call it chart ready, and we could say set chart ready is equal to use state, like that, and initially it's going to be false. So when it first renders, it's not going to be ready. Now in the use effect over here, the same one that we used for the current price, so from the other bug, we could create a set timeout. And what a set timeout does is it takes in a function. So this is going to be our function over here. And it also takes in a number of milliseconds that we could see here, which is basically telling it wait this number of milliseconds before running this function. And it actually works if we even put in 0. So once again, this is kind of a weird bug, but that's what happens with coding, especially using libraries that are really, really new. Sometimes you need to find these workarounds, but I think this is great for you guys to see. It's a good learning opportunity because this will probably happen a lot in the future with other packages that you use. So in this set timeout, we're going to wait 0 milliseconds. And once that's done, we'll say set chart ready to true. And that's going to be how we wait for it. Now, scrolling down to where the chart actually gets rendered, which is this, we can wrap all of this in some brackets, and let's go ahead and render this conditionally. So open the squiggly bracket, close it underneath. Basically, we'll say chart ready. So if it's ready, we'll have a ternary operator here. So question mark, if it is ready, render this. If it's not ready though, then we'll just want to render null. And if we save that, let's reload it. We could see that we could click it, click another one, all works, and we can reopen it and it works properly. So there you have it. We are officially done. We created this crypto price tracker that's very similar to Coinbase's price list. And we could go in, click any of the coins, click over them to get their price. We have the 7-day change percentage. We can click other coins. We can have this really cool animation. And we did all of this using reusable components for this list and also using real API data from the Coin Gecko API to populate all these coins. So give yourself a pat on the back for this one. This is a big project, and I hope you learned a ton from these past couple of videos. If you enjoyed this, please leave a like, please subscribe, hit that bell, and let me know in the comments down below what you liked from this video, what could be improved, and what you want to see next.